Today, I would like to talk about a topic in the chapter 2, which is 2.4 separation of oxygen and nitrogen from air. And in the class, I think we already discussed about that air actually is a mixture of gases, and we have oxygen, nitrogen, hydrogen, carbon dioxide, water vapor in our air. Because oxygen and nitrogen is very useful, that's why we would like to have some methodology to separate them from the air. And today we would like to introduce a fractional distillation of liquid air to separate the oxygen and nitrogen from the air. In here we have 3 steps, and the first stage is stage 1 is the purification of air. And the second stage is the liquefaction of air, and the final stage is stage 3 is fractional distillation of liquid air. Okay, then talk about the stage 1, stage number 1, the purification of air. Actually, the air is coming into the process in this direction, and then we'll have filter. First of all, to filter out some of the dust particle within the air. After that, the air will be passed to this chamber, and in this chamber, we'll cool down the air to around minus 80 degrees Celsius, and then the water vapor and the carbon dioxide will become a solid and removed by the filter. And the air, after this purification process, we will go to another stage, which is stage 2, liquefaction of air. Okay, in this stage 2, which is in the stage 2, we have this liquefaction of air, and the air will go into this chamber, and this chamber will cool down the air to around minus 200 degrees Celsius, and actually all the gases here will become liquid. That's why it means a liquefaction of air. And the air is then will go to the stage 3, which is a fractional distillation of liquid air, and we will handle it within a fractionating column. Okay, so let's zoom in a little bit. Within this column, and the liquid air is very cool, and then it will warm up very slowly. And because it warms up very slowly, when we reach the boiling point, for example, of the nitrogen gases, and which is minus 196 degrees Celsius, the nitrogen gas will change from liquid state to gas state and become the gases, and then it will go up to, within the columns, and then go to here, the upper part of the column, and then we can collect the nitrogen gases. And then using the same methodology, we will warm up again very slowly, and next it will reach the boiling point of argon. Then the argon will change from liquid state to gas state and collect in this chamber. But by the way, the argon gas we cannot go up to the chamber which collects the nitrogen gases, because in this chamber is the temperature is lower than the boiling points of the argon, and then it will change back to the liquid state, so the argon can only be collected here. Okay, finally, the oxygen, the temperature reach the oxygen's boiling point, and the oxygen become the gases, and we can collect it in here. Okay, then look back the whole process, And actually, the whole process is the design is come from the handling of the boiling point of the gases. So when the gases have the lowest boiling point, it will be collected at the upper part of the fractionating column. If the gases have the highest boiling point, and it will collect it at the lowest part of the fractionating column. And this is the whole process for the fractional distillation of liquid air. Okay, finally, you need to do some class practices, which is 2.5. And in here, we have a list of gases, and we also have different boiling points. Okay, so you can, based on the understanding what is in the fractional distillation of liquid air, you answer the questions A and B. Please write down your answer in your exercise book, and then you can take a picture on your exercise book and upload back to the Schoology. Thank you.